Part 3, Dessert. In this video, we will explore the concept of radiation, a type of heat transfer. By using an everyday example such as baking, we will discuss the different types of radiation and its interaction with matter. Cookware. For this exploration, we will use a dark, non-stick baking pan and a traditional oven. Radiation. One of the types of heat transfer that occurs while baking is radiation. Keep in mind that radiation is not the only type of heat transfer that occurs in an oven. Convection and conduction also play a big role in baking. Radiation is the energy emitted by matter in the form of electromagnetic waves as a result of the changes in the electronic configuration of atoms. When heat transfer takes place during the transmission of electromagnetic waves, we call it thermal radiation. This process requires no medium. Thermal radiation is responsible for the warming of the Earth by the sun's rays. The radiation caused by the immense energy of the sun travels to Earth at the speed of light and gives all living things the energy to grow. All matter, whether it is solid, liquid, or gas, gives off, absorbs, or receives thermal radiation. The quantity of radiation emitted, absorbed, or received will depend on the special properties of the object, which we will address later in the video. Animation 1. In our exploration, we will examine how thermal radiation is used to bake a cake. The incident radiation is the radiation that the oven emits and will come in contact with the cake. We must take into consideration that not all the radiation emitted by the oven will reach the cake. We will have losses. There are 4 things that can happen with the incident radiation. The radiation can be reflected from the surface of the cake. The radiation can be absorbed, which is ideal for the baking of our cake. For an object to absorb thermal radiation, the energy of the radiation must exceed the maximum limit of resistance of the object. The radiation can be transmitted to any other objects on the cake, such as the surrounding air or the pan. The radiation sometimes cannot even be absorbed by the cake. Emissivity. There are different properties that determine the quantity of radiation an object emits or absorbs. Emissivity is a measure of the rate of radiation an object emits and is denoted by the symbol E. It is measured against an object that emits radiation at a maximum rate. Such an object is called a blackbody. A blackbody is an idealized entity that cannot be found in nature and can only be approximated through experiment. A blackbody has an emissivity of 1. Emissivity chart. Different materials have different emissivity. They range from 0 through 1. This chart shows some common materials and their emissivities. The higher the number, the higher the rate of emitted radiation. Absorptivity. Absorbance is a measure of the rate of the radiation absorbed by an object, and it is denoted by the symbol alpha. Like emissivity, it is measured based on the maximum absorption rate of a blackbody. A blackbody will absorb and emit all its incident radiation. A blackbody has an absorptivity of 1. The chart here shows some different materials with their respective absorptivity. The materials with a higher number will have a higher rate of absorbance. The net rate of radiation heat transfer between 2 surfaces is given by this equation. E is the emissivity, alpha is the absorptivity, T is the temperature, and A is the area. And this is measured in watts.